Hello, judges. We're Cecilia, Giovanna, Charlene, Leila, and Cayenne.
Looking around our teachers' lounges, the vast amounts of coffee residue in bins struck us. Research shows 2.25 billion cups of coffee are consumed per day, and 23 million tons are left as residue per year. Our solution is to create an effective, natural, eco-friendly alternative to commercial fertilizers. It is inspired by agar, coffee residue, and eggshells, which three initial letters created ACE fertilizer.
Agar is a natural marine biopolymer, of which agarose, one of the primary polysaccharides of agar, has a double helical molecular structure. This is capable of holding water molecules in its interstices. This forms a thermoreversible gel-like substance in 1% agar solution, whereas in other hydrocolloids like gelatin, which are not only sourced from animal skin, ligaments, tendons, or bones, only are able to form gels at 20% gelatin solution, which makes agar the superior binding agent. Moreover, agar's diffusive property makes it a slow-release fertilizer, which eliminates risks of fertilizer burn common among commercial fertilizers, in which the immediate release of so many salts can cause harmful effects to plants in the form of moisture loss and leaf discoloration. Lastly, agar is able to decompose in soil through microbial action, which prevents soil and aquatic pollution more in comparison with commercial fertilizers.
Coffee residue contains nitrogen and other mineral ions, all necessary for healthy plant growth. Moreover, caffeine compounds in coffee residue have pest-deterring abilities, as this is able to inhibit the production of phosphodiesterase enzymes in insects. This causes an increase in one of the messengers in the insect's nervous systems, which then react with their octopamine hormone, hence affecting their metabolism, reproduction, and many other functions. Infrared spectroscopy further shows that coffee residue is acidic, as OH and phenol groups are capable of deprotonating. Alkaline eggshells, are thus added to counter it and cater to each plant's optimal pH level. Consisting of 95% calcium carbonate, eggshells are a very good source of calcium, which prevent the chances of getting calcium deficiency in the form of necrosis. Thus, we predict that ACE will serve as a fertilizer that slowly releases nutrients, helping plants grow at a faster rate while ensuring plant health, and all the while biodegrading within 3 to 6 months.
Though ACE fertilizer is slightly more expensive than commercial fertilizers, it is able to facilitate plant growth in a 100% natural, organic environment free of the risks of fertilizer burn, while also being able to biodegrade. Now, moving on, in part 1, ACE fertilizer is synthesized by boiling agar, eggshells, and coffee residue in the ratio shown above.
We then tested the effectiveness of the ACE fertilizer using the test parameters including growth rate, greenness of leaves, biodegradability, pH of soil, and dry mass. The stem length result shows that beans in ACE fertilizer grew 120% faster than beans without fertilizer, and had a similar growth rate to beans in commercial fertilizers, proving as an effective alternative. A t-test shows that beans in ACE fertilizer grew significantly taller than beans without fertilizer, with a p-value far less than 0.001. A t-test comparing ACE fertilizer to 2 of the 3 components shows that ACE also did significantly better. Thus, each of the components itself is a large contributor to such promotion of growth. Hence, ACE is the best combination. The greenest color test compares the leaf color to 4 different shades of green. The results shows that beans from all fertilizer are the darkest shade of green, thus indicating that ACE promotes the optimal chlorophyll content for plants. The biodegradability test demonstrates that the ACE fertilizer can fully degrade in the soil within 10 days, much exceeding our prediction. Thus, it is eco-friendly as it can be reabsorbed in the environment.
The pH soil test shows the pH of pure soil of ACE, and soil with commercial fertilizer are all 6, which lies in the optimal range of 5.5 to 7 for growing plants. The dry mass test shows that ACE plants have an average dry mass of 1.2 grams, which is more than the average dry mass of commercial fertilizer plants, which is 1.0 grams, and controlled soil plants, which is 0.5 grams. This shows that ACE plants are capable of accumulating more matter. Ultimately, ACE's slow release feature promotes stable growth. It is an effective, eco-friendly solution for mitigating the food waste problem. Extensions include experimenting with more plant species and adjusting the ratio of coffee residue and eggshells to adjust for pH, and to increase the duration of our experiments. Thank you all for listening.
唔該晒護江維多利亞學校嘅同學。